Okay, so let's add some multiplayer abilities into our game. And basically all we're going to do is add controls so that our second paddle can be moved up and down just as the first paddle is being moved. So we're going to go into our paddle controller script, and basically what we're going to do, so at the moment we have it checking for if the input is W or S, and it'll move the paddle appropriately. What we're going to do is add a check to see if this is player 1 or if it is not player 1. And the way we can check that is by adding a value up here, which will be a public bool that we'll call is player 1. Nice and simple. So what a bool is basically a value that can be either true or false. A bool is technically either 0 or 1, but is commonly used as either true or false. So what we'll say is if our bool is player 1 is true, then that means we'll use this bit of code, and if it's not true, we'll do a different bit of code. So how do we apply that here? Well, basically what we'll do is just above we're checking for where our input is, we're going to add a new if statement and say if is player 1. And when we check if is player 1, because it's just a bool and it can be either true or false, what we're saying is if is player 1 is true, then what we're going to do is run this whole little bit of code. And the way we can make sure that we run this whole bit of code is putting a curly bracket before, and then just after we're going to put another curly bracket. But the way coding is indented in C# in general, or just coding in general, is to make it nice and easy to read by making things that are within a bracket moves over to the right. At the moment it's kind of confusing that this bracket here is on the same line as all of these stuff here. So what we'll do is highlight all of this, we're going to right click on it, and we're going to say indent selection. So that moves it over to the side. So then we know that all of this stuff here is within this little bit of code here. So we're within if is player 1. So if we are player 1, then we're going to use W and S to move up and down. But if we aren't player 1, so else, what we're going to do is copy all this bit of code here, and we're going to use two other values to control the up and down motion. So for this example, we're going to use O and L. Now you could equally use any other objects on the keyboard, any other letters, but you could also use the up and down arrows. So let's, for example, keycode dot up arrow we could use, or we could use numbers, or we could use enter and shift or anything like that, but we'll just stick with using keycode.o and keycode.l. So this will control if our paddle is not marked as player 1. Okay, so that's our two different types of code setup, our two different types of control setup. So let's save that, and we'll go back into the game here. And basically all we do now is on our paddle controller, or on our individual paddles, once the script is compiled, what we do is we see now we have this bool here for is player 1. So I'm on player 2 at the moment, so that's obviously not going to be player 1. Let's switch back over to the other paddle. We're going to set this as player 1. And now, if we hit play, and if I can manage to control two different things while talking, we should be able to move them around individually, just like this. And let's see if I can manage to keep a bit of a rally going. But as you can see, now we have two different players playing our game, so you can have a bit of fun with someone else as we're going. It's getting a bit fast, couldn't handle it. Okay, but there you go. That's how we can add some simple bit of multiplayer into our game. But at the moment now, our scores keep going forever. So let's add a system so that when our players reach a certain score, they get a message that tells them they won the game. Okay, so our players are now able to play a two-player game, but of course we want to make it so that when the players reach a certain score, they can either know that they lost or know that they've won the game. So what we'll do is basically we're going to add a screen that says the player has won the game. So what we're going to do is create a new canvas. So we're going to go to game object up here, and we're going to go to UI, and we're going to create a new canvas, and this is going to be when we described the different types of canvases before. We're going to leave this as the large huge size one that we had before. And then on this canvas, we're going to create a new UI object, a UI text. And we're going to zoom in a little bit. I'm going to make this text be white. Then I'm going to make it just say X wins. And we're going to adjust that to say either player 1 wins or player 2, depending on who has won the game. So we're going to make that font size a little bit bigger. I'm going to center that as well. If we look at our game view, we can see now X wins appears in the middle of the screen. Okay, so now that we have that, let's actually go and look at making some code that will carry this out. So to do that, we're going to go into our game manager script, which is right over here. And what we're going to do is, first of all, we're going to create a reference to that bit of text that we just created. So we're already using the uniengine.ui, so we don't have to include that again. But we can say public text win screen. Oh, if I spell that with a small c, it'd probably be handy too. So what we'll do next is basically check within the update loop and check to see if our player has reached a certain score yet. So we'll go into our update, and what we're going to do is here is say if score 1 is greater than or equal to, let's pick a score value, let's say 10. Actually, let's make it so that this is adjustable. So what we'll do is up here, where we have our win screen, we're going to say public float, public int score target. So that'll be the target that we want our players to get this. So this will be adjustable, so you can make changes to it within your own game. So we'll say score 1 is greater than or equal to our score target. So if the player's 1 score is the same as or somehow greater than, if somehow the ball very quickly went into a goal zone twice, it shouldn't happen, but it's best to make sure that we can catch those situations if it does happen. What we'll do is, by default, if we go back here, we'll have this object deactivated. So I'm going to deactivate it here, and it should turn off in the world. Why didn't it? There we go. So by default, we're going to have that deactivated. And then what we'll do is, if our player gets that score, or sorry, if the player 1 reaches the score target, what we'll do is say, okay, activate that text object. I'm going to say win screen dot game object dot set active is true. So what we're doing there is just activating the object within the world. We also then wanted to display that because player 1 has reached the score target, we wanted to say, okay, player 1 wins. So we'll just say on the win screen, we want to access the text object that's on it, much as we did before, and we want to set that to be equal to player 1 wins. Nice and simple, nice and straightforward. And then the next thing we want to do, obviously when our player reaches a score and the game is won, we want to deactivate the ball from bouncing around the screen, because we don't want the ball to keep going and our player to keep racking up a score. That's no good. So what we'll do is we'll create a reference to our ball object. So we'll say public game object ball, and then down here we'll say, okay, the ball object, we want to set that, we want to say set active false. So we're deactivating the object so it's no longer bouncing around within the world. And that's basically all we want to do with our score tracking. So we'll do the exact same thing here, and we're going to paste it in there like that. And then instead of it being if score 1 is greater than target, we'll say if score 2 is greater than target. Then in that situation we want to say player 2 wins. So I'm going to save this, and we're going to pop back into the game here, and we're going to hook up a couple of those little bits of script that we just created. Once it finishes compiling, we'll go to our game manager here. So now we have a slot for the win screen, so I'm going to drag that bit of text in there. Our score target, I'm just going to set that to be 3 for now, to keep it nice and simple. And then we're going to drag our ball into the final slot like that. And then we're going to hit play. And now we should see, once the ball wins the game a couple of times, like this, and then finally like that. There we go. We get player 1 on screen. The ball is now gone. We can still move around our paddles, but that's perfectly fine. That's perfectly usable. And we now have the basics of our game pretty much in place. There's nothing else really to it. The only other thing at the moment is, now that we finished our game, hey, like, it'd be nice if we could just play the game again straight away. So let's add a way to reset the game. So what we want to do now is to be able to reset the game when our players have won a match. Or to be honest, at any point really is when we're going to reset it. But functionally, it'll be most useful when our players have finished the game. So what we're going to do is, in here, we're going to go into our game manager script, and we're going to add a little bit of code that will make it so that whenever our player presses the R button, it'll reset the game. So what we're going to do is, just below where we're checking to see what our score is, we're going to add a new if statement and say if the input.getKey. What we're going to do is check when getKey is pressed down, not just when it's held down, because then what will happen is, if someone was to hold down R, for example, the game would keep resetting over and over and over again. But what we want to do is get key down, because as we talked about before, get key down happens the first moment that a key is pressed. So as soon as our player presses the button, and the button we're checking that they're pressing is keycode dot R. So as soon as that happens, oh, we need a second close bracket there. It was confusing itself a little bit. So the second that happens, we want to run a little bit of code in here. And a little bit of code that we want to run is basically so that it will reload the current scene that we have open in our game. So back in Unity here, at the moment the only scene we have within our world is our level 1 scene. So when we're running the game, basically anytime you're doing different levels within a game, it'll be running in a completely different scene within Unity. So what we want to do is, if we're resetting it, we just want to reload this scene back to its default state. So to do that, we need to access the scene management of Unity. And to access the scene management of Unity, much like we did with the UI, we have to go up here and say using Unity engine dot scene management, like that. And so then when we press the R key, what we can say is, okay, go to the scene manager, and we want to load a new scene, and the new scene that we want to load is the currently active scene. And the way to check what the currently active scene is basically to say is scene, go into the scene manager again and say get the active scene. So get active scene. We want to put a couple of brackets there, and then on the active scene we want to get the name of that scene. So whatever the name of the active scene is, we're sending that out and telling it to load that scene. It's slightly an awkward way. There was previously a much simpler way to reload scenes within Unity, but they've kind of changed it so that now in the current version of Unity it's a little bit more awkward. But once you get used to using it, it becomes kind of second nature. So we'll save this and we'll go back into Unity, and what we'll actually see when we go to test this out is it'll cause an error, but we want to demonstrate that first, and then we'll explain why it causes that error. So that's compiled. We're going to hit play, and once this is going, we'll just let it play for a second. We can see we've got a score of 1 and 0. If I hit R now, oh, it actually did reload the scene. I thought it might not reload the scene because there's a slight error that happens with the scene management, but because we didn't encounter it, we can actually explain it a slightly bit later when we will have it happen to us when we go to add a main menu to the scene in just a couple of videos. But for the moment, we can happily know that it will actually reset the scene just the way we want it to. The only other thing now is our players don't magically know that pressing R will somehow just reset the scene. So what we're going to do is we're going to zoom out to our big canvas again. I'm going to activate our little windscreen text. And what we're going to do is create another bit of text below that. So we're going to right click on it and create a UI text. So it's a child of the current bit of text. We're going to make this white as well, similar to previously. I'm also going to make this a little bit wider just because we can. I'm going to hold Alt to make sure I'm stretching it out equally. I'm going to center this bit of text and then we're going to move it down. And basically all we're going to say is press R to reset or to restart the game. So what that'll do is just, it lets the players know that, okay, you've won the game, now you can press R and it'll restart the game. So I'm going to deactivate again the parent one, which is the whatever player wins. I'm going to deactivate that, and that'll deactivate the child. But then what will happen is, as soon as this object becomes active and it says player 1 wins, the child object will also become active within the game. So now we can reset the game happily and we know what's going on. So now that we've worked out how to make our players be able to play the game together, let's add some simple kind of AI into the game so that we can have a single player game and be able to challenge ourselves to practice more and more as we go. Okay, so we've got our 2-player game working just the way we wanted to, but the next thing we want to do is actually make it into a single player game and add some basic AI to our little player 2 paddle over here on the right. So to do that, the first thing we're going to do is save our current scene as a new scene, and what we're going to save it as is, we're going to go save scenes and then save scene as. Make sure we're in the scenes folder, and we're going to save this one as multiplayer, and then we're going to save it again. We're going to say save scene as. In our scenes folder, we're going to save it as single player. Okay, so now that we're because we just saved it as single player, we're working within the single player screen, or within the single player scene even. So now we're going to make some changes to our paddle controller script to control player 2 over here. And the way we're going to do that, first thing we're going to do, we're going to go into our paddle controller script, of course, and we're going to go to our variables up here, and we're going to create a new variable that we're going to call public bool is AI. And this is basically going to be a simple check that we're going to add in at the start and make it so that we can't use input keys to control anything else. So at the start of our update loop, we're going to add a new function or a new if statement that says if is AI, and if it is the AI, then we're going to do some movement code in here to make it try and hit the ball. But if it isn't the AI, then we're going to add this little else bracket and say, okay, if it isn't marked as AI, then it must be either player 1 or player 2. So we can do all this bit of movement code here. So we'll put a close bracket just after all that. And much like we did before, we want to make sure that is all indented. So we'll right click that and indent the selection. So now we know we're doing, okay, if we are an AI, then we're going to do a bit of code here. Otherwise, do the check and see if we're player 1 or player 2, and then move it as appropriate. Okay, so the next thing we want to do is actually make it so that our AI will be able to try and follow the position of the ball, basically, as it moves up and down the screen, and then move into the right position to try and make it bounce back against the player. So what we'll do is, if we're going to be following the position of the ball, we need to know where the ball is at any particular time. So we're going to need a reference to the ball itself. So we're going to say public game. Actually, we won't do. We'll do specifically to the ball controller. So our ball controller is the script we created, and what we're doing now is saying, okay, we're going to make a reference to the specific ball controller script, and we're going to call it the ball. And then what we can do in our start function here, rather than having to go and assign it in our inspector like we've had to do previously every time we wanted to do anything, we've gone say, okay, we want a reference to the ball. Let's make sure that the ball is attached to the right paddle. What we can do instead, to kind of automate the process a little bit, is just say in our start function, we can say, okay, the ball should be equal to find object of type ball controller. Oh, no, I'm not typing the right thing there at all. Ball controller. Like that. And so what that'll do is it'll search the current scene and find any object that has the ball controller script attached to it. And because we know there's only one object in the scene that will have that script attached to it, we know that it'll find the exact ball that we wanted to find. So now that it knows where the ball is, we can use that to control where we're moving to. So what we'll do is, if we rd AI, we'll say, okay, if that's the truth, then transform.position should be equal to, instead of making it equal to a new vector tree, what we're going to do is make it try to move toward where the ball currently is. So it won't just try and match exactly where the ball is, it'll move at a certain speed towards where the ball is. And the way we do that is by using a vector tree dot move towards. So what move towards does, if as soon as you hit the first bracket, you'll get this little tooltip that kind of gives you an idea of what it is. As it says, it moves a point current in a straight line towards the target point. So basically what we have is where our current position is, we want to go towards a certain other object, and then we have the amount of distance that we're allowed to move towards that object. So the first value will be where we currently are, so that'll just be our transform dot position. Where we want to go towards is a new vector tree. On the x-axis, we don't really want to move left or right at all, so we'll just use our current transform dot position dot x. On the y-axis is where we're actually wanting to do something interesting, which is we want to follow along with the ball. So we're going to say the ball dot transform dot position dot y. And then finally, again, we don't want to move anywhere on the z-axis, so we'll say transform dot position dot z. And then at the end here, we have how much distance we're going to be allowed to move at any particular time, and of course that will be basically our movement speed. So we'll use the value we've used before, so that'll be our speed, and we're going to multiply it by time dot delta time, just as we did before, for the exact same reason. We don't want the paddle being able to move around like crazy. So now that we have that in place, and need to make sure we put a semicolon at the end, save that, and we'll go back in here. And now we should be able to see this paddle moving around in operation. As I said, it's a very simple AI, but it works perfectly well for our goals and for what we wanted to do. So we have paddle 1, or sorry, our player 1 paddle is perfectly fine as he is, but our player 2 paddle, we're going to scroll down here and we're going to set the AI to be true, and then we don't need to hook up the ball at all because that will automatically find it. And then we're going to hit play. And now, once it's going, you can see it's following along, trying to keep up with where the ball is. Now, the important thing then is to try and adjust how fast it moves to be able to keep up with the ball. Because at the moment it's making it very easy. You can see you can follow along quite well with the ball. A lot better than I can. So what we'll do is adjust the speed of our computer paddle to be down to 6. And we'll play again. And basically it's about finding the balance. So you adjust the speed to make the second paddle, or the computer paddle, whatever you want to refer to it as, to make it easier or harder as you go. So what you could do is set up multiple scenes with different speeds on each paddle, so that you would have, say, an easy speed, a hard speed, or a mega hard speed, whatever you want to do. But you can see now we've got this basic kind of AI in operation. It's following along with where the ball is. It's kind of playing the game. It's kind of trying to keep going as it goes, and it's trying to keep up. And it's just a simple, straightforward AI. So we want to be able to quit out of a game when it's in the middle of running or at any other point. So I'm going to switch back over to our single player view here, or single player scene, sorry. And what we're going to do is add the ability for if our players hit escape, it'll quit out of the game and bring them back to the main menu. And to do that, all we're going to do is go into our game manager, and this will be automatically applied to both of our scenes because we're making a change to the script, not just to what's within an individual scene. So what we're going to do is say if input that get key down, if we find the player pressing the key code for escape, so if they press the escape button, what it's going to do is we're going to tell it to go into the scene manager, and we want to load the scene main menu, because we know that's the first scene that our players are going to encounter. We're never going to change that. We're always going to have our players loading into the main menu scene, so we can make sure we can be happy in the knowledge that we're hard coding that into the game. So we're going to save that, then we're going to pop back into the game here. We're going to let it compile. It should take a second or two, and then once it's done we can go into our game, hit play, and you can let it play for a second, and then if we hit escape, there we go, we pop back out to the main menu. If we go into multiplayer, we can hit escape, it goes back out, and of course then we can quit out of the game. So there you go. That's pretty much everything in our game built. The next thing to do is actually finalize the game itself and export it into something that's playable by our players. So now that we've got an AI set up to play single player games, and we've got the multiplayer scene as well so that we can play 2-player games, let's make a main menu screen that we can actually use to choose between those two different games. So what we're going to do is create a new scene. So we go File, New Scene. We're going to go to a game object here. We're going to go to UI, and we're going to add a button. We'll zoom out here like this. I'm going to put this button here in the middle. Then we're going to change the text that the button currently says. So I'm going to go here, go to text. We're going to make this say single player. Oh, no, we don't want to enter. We want to have a space there. I'm going to duplicate this button like this, and I'm going to move it down. So now this one will say, if we go into the text, this one will say multiplayer, like that. I'm actually going to move both of these buttons down a little bit more, and we're going to add a bit of text just above them. So we'll go UI text. I'm going to make this quite a bit bigger, like that. Put it in the position in the center. Then we're going to scroll down. We're going to make the color white. We're going to make it just say the name of the game, which will just be tennis. Make the font much bigger, and we'll center the text as well, like that. There we go. We've got a basic little screen. I'm actually going to change the camera background too. We want to make sure that it stays as the black background we've been using. So we've got single player and multiplayer in our game. So now we need to write a bit of code that will allow us to actually use these buttons. Because at the moment, if we press play, we've got these little buttons here. But of course, if we click on them, all that happens is they go a little bit dark. They don't actually do anything. So all we want them to do is actually load up our levels, which is our multiplayer and our single player levels. So let's create a script that will be able to let us do that. So we're going to go in here, we're going to create a new C# script that we're going to call our main menu, and we'll open this up in MonoDevelop. Actually, rather than just being able to go into single player and multiplayer, we should actually add a third button into the scene also. So I'm going to duplicate our multiplayer here, and we're going to put that just a little bit below there, and we're going to change the text on this to be quit game. so that our players can get out of the game. You're not just having to tab out and force it to close or anything like that. Okay, so we've got that there. Oh, I should actually save this scene, shouldn't I? We're going to save this scene as our main menu, and we'll go into our main menu script. So in our main menu script, we're actually going to delete our start and our update because we're not going to use them at all. Instead, what we're going to use is a couple of custom functions. So we're going to create a public void that we're going to call load single, and that's what we're going to use to load the single player levels. Then we're going to create a public void that we'll call load multi, which will be what we use to load the multiplayer levels. And then we're going to create a public void quit game. Oh, we've been tabbed in there by accident. Public void quit game, which, self-explanatory, we'll use to quit the game. So to be able to load into different levels, as we did with our game manager to reset the scene, we need to use the scene management of Unity. So using Unity engine dot scene management, like that. So then to load our single player or our multiplayer, we need to know the names of the levels that we want to load. So here we're going to create a reference to the names of the levels, and that will be a public string single. So this is the first time we've encountered strings here in the course so far, and strings are basically a collection of letters. So any kind of word would be a string, a sentence can be a string, a single letter, a single number, anything like that would be a string. It's basically a collection of letters, numbers, characters, whatever, written out in a row. So this is how we'll use to store the name of the single player scene, and we'll also create a public string for the multiplayer scene. And then all we have to do in load single here is say, okay, when we want to load the single player level, we go to scene manager dot load scene, and the name of the scene we want to load is whatever is stored in our single string. And then here we'll do the same for our load multiplayer. For our scene manager dot load scene, and instead of single we'll use multi. And then finally down here for a quit game, we do something slightly different. All we do is type application dot quit, and that will make us quit out of the currently running game. Now we won't actually be able to test that within Unity because it won't make you quit out of the whole of Unity, which would be incredibly unuseful. But just take it for now that it will work, and we will test it out when we build the final game. Okay, so now that we have all our script written, we can go and hook these up to our buttons and make sure that they actually do something. So we'll let that compile just there. And once it's finished compiling, we're going to go to our canvas here. We're going to add our main menu script to that, like that there. Then we need to give the names of the scenes that we want to load up. So I'm going to go to our scenes folder here to make sure that we get the exact right names, because again, you have to be spelled the exact same way and capitalized the exact same way. So on our single slot here, we need to type in single player, just like that. And then on our multi slot, we'll type in multiplayer, which is the name of that scene there. Okay, so we've got those two things referenced there. So now let's make our buttons actually do something. So I'm going to select all three of our buttons here like this. Then we're going to scroll down, and where we have on click here, this is basically how we're able to run any bit of code that we want to run. So what we're going to do is hit the little plus button, and then what that does is create this little thing here with a slot for where a script is that we want to run a function from. And we know we just attached the main menu script to our canvas, so we're going to click and drag our canvas into that slot there. So now it's selected and it's applied to all three of our different buttons. So let's now go to individual buttons and make them actually do something. So on the first button, the single player, we're going to go down to the bottom, and here where it says no function, what we'll do is click on that, and we'll go to the main menu, which is the script we just created, and then we want to use our load single function, which will load the single player level. We'll do the same for the other button where it says no function. we're going to go to our main menu and load the multiplayer button. And then finally for the quit game, we'll go to main menu and then the quit game button. So there we go, we have our 3 different functions all working just the way we want. Now if we hit play, there is going to be a bit of an error when we try to load into a level. And this is the error that I thought might have occurred when we tried to reload the same scene that we were in, but instead it will certainly occur when we're trying to load into a new scene. So as I said before, the quit game button won't actually do anything. It won't throw us an error, but it won't make us quit out of the game either. But if we click on single player here, we'll get an error down here that says single player couldn't be loaded because it's not been added to the build settings, or the asset bundle has not been loaded. And the reason we're getting that is because, as it says here, it hasn't been added to the build settings. So what we have to do is go to File and go to Build Settings, and any time you want to load a level within a game, you need to make sure that it's included in the final build of the game, basically. So what we'll do is we'll make sure and drag in our main menu, our multiplayer, and our single player. So these are the 3 scenes that will be accessible by players when the actual game is built. And we also want to make sure that the first thing that the players see is the main menu. So whichever scene is first in the order here, that will be the scene that loads up as soon as the game starts. It doesn't matter about the order for any of the rest of them basically, but for the first scene we need to make sure that is the main menu. Okay, so now that the 3 of them are added into our build, we can close out of that, and now if we hit play, what we'll get is our game loads up again. And now if we hit single player, we can load into our single player game with our AI opponent playing away. We'll stop the game and rerun it, and if we hit multiplayer this time, we'll load into our multiplayer game so we can move up and down to our heart's content. So that's how we can navigate into our different modes and have the actual kind of feel of a proper game in action. But of course right now all we can do is keep restarting this game over and over again, or what we would also like to do is be able to use the common button of hitting escape to quit back to the main menu. So we're going to add the ability to do that in the next video. Okay, so now that we've got all the functionality of our game in place, we can play some single player games, we can play multiplayer games, we have our score target to say when one of the player wins, we have our main menu so we can choose individual options, and we can actually quit the game itself. The final thing that we need to do is actually export this so that it's a game that anyone can play. And how we do that is we go to File up here, then we go to Build Settings. The next thing we want to do is go to Player Settings down here in the bottom left, and then we can choose, so we have a company name up here, so I'm just going to leave that at James. We've got a product name, which is the name of whatever our game will be, and that'll be the name that's applied to the icon on the desktop of the game. We've got a space here for a default icon and a default cursor, so you can add in your own custom image for what the little icon on the desktop of the game for the game will be. But by default it'll just be the Unity symbol, and that's most of what we want to stick with. The only other thing we want to do is we want to, where is this? Supported aspect ratios. There we go. We want to make sure that our player is locked to be at 16:9 because we built our game around being 16:9. We want to make sure that our players will only stick to that so they don't see extra bits of screen and extra bits of random space that they don't need to see, and also to make sure that nothing gets cut off by a different viewpoint. So we want to disable all of these other ones and make sure that only 16:9 is selected, and that way our players will be, we're sure that our players will have the same view that we want them to have. And that's pretty much it. That's all we really need to mess around with. You can mess around with the other values as well. For example, there's a splash image when you load into the game. We've got other various different settings you don't need to worry too much about. But for now, all we're going to do is then hit the build button here. And what we'll do is create a new folder that we'll call builds. And then here we're going to say tennis version 1. We're going to save that, and then it'll take a few minutes to compile the game, depending obviously on the size of the game itself and the complexity of everything. This is a very simple game, so it won't take very long to build it, but the more detailed and the more of everything that's in your game, basically, the longer this will take to do. But for now, we should just be able to wait for this to build, and then we'll see our final files in action. So once the game is finished in building, it'll automatically open up the files that are outputs. So we've got this folder where we've just built our game into. So we've got our default files here, or sorry, not our default files, our completed files here. It's important to remember, if you're sharing this game with anybody else out there, it's important to remember that you need to give them both of these things. If you just give them the exe file, the game won't work. It needs the folder that contains data for the game also. So if you're sharing this with anyone else, you need to make sure to get both of these files, and then you can just hit the tennis exe file here. So we'll get some options for different resolutions. I'm going to stick at 720 there, and then we can hit the play button, and then once it finishes loading, there we go, we've got our main menu here in operation. We can hit the single player button, and now we can play our game and see how badly I can lose against the computer. Oh my god, I actually managed to get a point. But there you go, that's our complete tennis game in operation. So the best thing to do is just try and build this game for yourself and adjust the scores and see how it feels to play with other people. And then we'll move on to making our next game in the next set of videos.